Hello, and welcome to the Argyle CISO Leadership Forum. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsors' virtual booths at any time during today's event and for the following week. To ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. Now, without further delay, I would like to introduce our speaker, Rick Doughton, VP and CISO, Healthcare Enterprises, Centene Corporation. We're excited to have Rick with us for a keynote presentation titled Cyber Threat Mitigation in the Cloud. Welcome, Rick. Over to you.
Thanks, Nick. Very happy to be here. And thank all of you for sticking around to see me back clean-up. I really appreciate the opportunity to come back and speak with you all. I did this last year and really enjoyed the time. And feel free to go ahead and ask questions throughout. I will be happy to address them as I go. They will transpose them into the chat, which I will see, and then I will answer them. Go ahead and get started. The thing that I'm talking about today, of course, is cloud security. And I'm on the board of the Cloud Security Alliance here in Charlotte, where I am, and very active in the organization globally. And one thing that I keep saying is that when people ask me about how you do security in the cloud, they say, well, you can just get an IDS, right? And I'm like, no, that's not how it works. And so it's almost like we need a t-shirt. No, that's not how it works. It works differently. And so that's what we're going to talk about today, is all the unique things about cloud security that are very different than what we did in data center and on-premise security. And so first, by talking about, what are really the unique aspects of it? And so these are some that I kind of came up that I talk about all the time. One of which, of course, is that the whole definition of the cloud is the fact that it is on-demand, self-provisioning, and elastic. And it could be in many different types of services. It could be your own private cloud, and I'll talk about that in a minute, or public, or infrastructure, or software as a service. But everything is on demand. You don't have to put up boxes together and get things installed like you did before. The second thing is it's a shared service model, because you have one of the cloud service providers maintaining the infrastructure, whether it's infrastructure of service, the underlying hardware and power and utilities that go into that. You just have this abstraction over this metastructure of, building your own servers and doing different things. Or if it was platform as a service, you may have something a little bit less control. And then software as a service, you have even less control. And I'll talk about that in the next slide. It is outside of perimeter controls, because we may have, firewalls on our perimeter. We may have IDS looking at things. We may have things on our endpoint, but the cloud is completely separate. So it's outside of that, what we're used to. Obviously, we don't live in castles anymore. And even in cybersecurity, we have a deperimeterization, campaign that's been going on for 20 years now, it seems, and understanding that there is no edge to it. And this even makes the edge in multiple places distributed around the world. The concept of a software-defined network, we're not plugging boxes into switches and plugging switches into routers. It is all software defined, and it's all these virtual networks, which can be very, very big or very, very small. So the isolation is much more interesting, which is great from a security standpoint, but also challenging from a visibility and a telemetry standpoint. The dynamic environment, the dynamic elements of this, that we have temporary workloads, we have containers that are spinning up and spinning down. We have whole servers that you can just launch. We can have servers that can expand in the elastic aspects of it and go away. And if anything happens, you're like, well, what happened on that after it went away? It can be hard to determine. The last three things, like, you don't control the logs. A lot of the logs are maintained and managed by the cloud security service provider. Sometimes they're not well documented. Sometimes they chain without telling you, and sometimes they're hard to get to. And they're not easy to be able to find. So that's kind of one element when you're trying to get telemetry, which is going to be my theme of this talk, is like, how do you get telemetry to know what's really going on so that you can respond to it? Because incident response is very different, and forensics is very different. You don't just run in case to do an acquisition of a box when it comes out of trust. It's isolating it will be different things, different ways than you've done before on endpoints and things like that. And I'll talk a little bit more later. And then finally, the metastructure, which is the underlying infrastructure that the cloud provider maintains is its own attack surface. And while we kind of trust them, and they're much bigger companies than most of us anyway, they're probably doing a better job than we would do ourselves, it's still a blind spot. And if we don't see that, it's kind of, it can be scary, or a risk that we need to kind of manage. So quick 30 seconds on shared service model. This comes from the Cloud Security Alliance. This graphic, and you just see at the bottom, there's infrastructure as a service, which is the metastructure of the facilities hardware layer, and then the abstraction layer, and then APIs. You're integrating with that. And this is where you will spin up your own servers, you apply your own applications, you'll do all the things that you would do, set up your own virtual networking on top of this, just like a real data center with hard physical boxes, but the boxes are all virtual. There's the platform as a service, which is a specific, usually it's a platform like Oracle being one. I could probably say that Office 365 or Gmail is also like a platform as a service, because you control all the aspects of the data that goes into it, the access controls of it, and all of the different things, but you don't own the underlying application. And then finally, software as a service, which is your standard, Salesforce being the easiest one of that. As an example, and in all your many organizational back office platforms that are, you really just are a user of this application and you get a login account. You may be able to do some modifications to it through no code or low code quote programming to be able to change it and customize the forms to look the way you want for your organization, feedback to your authentication systems, and feedback to your data sources. But you don't own the application. So as you go up the model, you have less and less control and visibility, and that becomes a challenge. So when the Cloud Security Alliance last year put out the top 11, and I don't know why it's 11, maybe they like prime numbers, cloud threats. And then the next screen is like one of what they've been realized, what are the top ones for this year. So last year, you can see in reading through these that most of these are user error, that I don't have, I'm not managing my credentials, my APIs are insecure, I'm misconfiguring stuff, I don't have secure development, I have insecure third-party resources, I'm not managing my vulnerabilities, my data is exposed, I'm, misconfiguring server workloads, all of these are more human error. It's not, none of it is really inherent to the cloud as an architecture or as a concept. It is what we've done to, and I used to have this, I ran pen test teams from the late 90s to late 2000s. And early in the days when we were doing like PeopleSoft and SAP applications, would always say that it's really secure until you start messing with it. And as an organization like took an SAP implementation, this is still, this is 20 years ago, on site, and it's all, all the things they do to update it, and they do all the things that I talked about with the software as a service, it became less secure because they put in this role-based access, they added these different layers, they added these different things, and it became less secure. And so those kinds of things, like the humans make things less secure that may be inherently secure. So, and then the final 10, like organized crime, these are more like threat vectors than anything else than the other ones. So then we talk about the attack vectors. And so this is now a year into it, as we start looking at, from when we put that list together, we look at like, what are we seeing? And again, you see most of them are human error, but more importantly, you see that most of these are with credentials. So yes, exploitable workloads, but excessive permissions, insecure keys, the most common thing. Even for the last 10 years, you got to say, don't leave your S3 key in an open, the repository on GitHub, because, that still happens today. So insecure key, exploitable authentication authorization, and unauthorized access to different object storage where you're keeping your data, and then account access to third parties across the environment. So again, looking at this, 7 of the 8 of them are related to identity issues. Whether things are encrypted in the 7, whether they're encrypted and compromised images, are kind of like one of those also ran like 10 and 11 from the previous one. But that's the important thing, is make sure that you have rigor in your process is the main thing. So here's where like the meat of it. I only have like 3 more slides after this. So I know I have another 20 minutes, but The if you do development in the cloud, and particularly greenfield development, then this is what really applies. But even if that is things you're doing with the software as a service and modifying that software to fit your organization, these things still apply. So we used to have, well, we still do, a system development lifecycle, the SDLC. Now that feeds into a pipeline, which I kind of put in the box over here on the right, within the cloud in the ultimate version of DevOps, development operations. We want it as automated as possible. And if you kind of thought about DevOps like the old Scrum, the Scrum models of agile development. So there's agile Scrum or XP or whatever version of agile you're doing. It was a quick cycle of I'm going to do a sprint and then I'm going to test it, and then I'm going to go back and do a little thing instead of this waterfall going through. DevOps is really the automation of that. And if we talk about DevSecOps, then it's the automation of security overlaying that. So while you have a system development lifecycle, which may be whatever method you want, it will feed into this CI/CD pipeline, which is continuous integration, continuous deployment. That's the automation part. And so within that, there is the planning, coding, building, testing, blah, 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 going through there. The SDLC is really this, but it feeds into this longer thing, because if I look over here on the application security stack of the CI, of the things I'm doing within the CI/CD pipeline, it transfers and transitions into the infrastructure. So, it's not like the developers would put something in development and then ask to be moved into production. They're doing all of that. In fact, they're spinning up the environment to be able to put into that. First question in, what do I think leaders flounder most when it comes to cloud security? I guess understanding differences. That's an excellent question, because the differences that I'm describing in the very first slide, they think it's the same way. They think that they're going to put firewalls, they're going to EDR, they're going to put IDS, and all the traditional things we've done for 20 years. They don't apply the same way in the cloud. And then when we get into incident response and forensic, your incident response plan, very, very different, because the tools that you did on-prem are very different than, you're using cloud native tools to be able to isolate, to be able to copy an image, to be able to, and you can't get memory images out of some of these things. So your process is very different. So I think that they don't appreciate how different it is the main thing. It's not just, we shifted our servers to the cloud. The architecture is different. And the second question is, what's one cost-effective thing we can start doing today to improve cloud security? Oh, excellent question. Visibility. Know what you have. Understand the telemetry that you have. Be able to know what is being logged and where it is, so that you can be able to identify any issues in that. You don't have to buy any tools. Yes, there are posture management tools for your containers. Yes, there are tools that can give you, a single pane of glass for that, for asset management. But the beautiful thing about the cloud is that nothing happens without being logged. You can't just, someone can't just set up a computer and plug it into the network like they can in your office, and nobody knows about it until maybe some telemetry lights up because, hey, what's this new IP address? In the cloud, there is a log of who did it, when it happened, what it does, how long it is, how big it is. Nothing happens without, but you have to know where those are. And so the first thing I would do is absolutely look at what telemetry you have and what's being logged. And you may not realize you have certain things turned off. Question 3, and thank you for answering the question. Again, I have few slides because I like to answer questions. What aspects of cloud security control stack can I focus on to be sure initiative deliver the most bang for our cybersecurity buck? Okay, good question. That leads into what I'm about to talk to. So if we look at the stack over here, when we talk about development, threat modeling is number one. I'm so happy that the cloud brought threat modeling back from the dead. Threat modeling we were doing in the early 2000s. Microsoft published a book about it in 2005. It's got a little bit of a heyday in the late 2000s, and then it kind of like went by the wayside. But threat modeling is doing a paper-based risk assessment of all the assets, the access entry points, and the access levels into everything to kind of do a design risk review before you write any code. Then static and dynamic code analysis, which is very traditional, application architecture insight, which are tools that give you a map of what is going on in the cloud in your application environment, because you have different, secrets management tools coming in for the credentials. You have lots of service accounts. You have different data sources. You have different APIs. You have different things that are feeding in from production into a website, for instance. And so just these architecture insight tools that fit below the posture management tools. The architecture insight tools are things that I would consider like a Bionic or an Oak 9 or a Sysdig. And when we talk about posture management tools, which are really kind of vulnerability management tools for the environment itself, are things like, Prisma, Wiz, Orca, things like that, Lacework, things like that that are really looking at the posture management to kind of give you. Then there's permissions management, data protection. There's so many data protection tools out there now. API security, looking at the credentials of your API, the security of your API. And then going back to the thing about software as a service, the no code, low code. So those types of things. So going back to the question, what aspects can I focus on to be the most bang for the buck is going back to like telemetry and knowing where, A, what is being logged and where it is, and B, understanding all of the vulnerabilities related, because this is really a vulnerability and configuration management challenge, because everything is automated. And where before there's a new patch on Patch Tuesday, and once a month we kind of get it all rolled out, and et cetera, et cetera. Here, these could be going up in minutes or hours, and we need to make sure that we understand that these temporary workloads aren't just going to be re-imaged with bad stuff on it. So going back and understanding what that whole life cycle is of your workloads, and understanding what the root cause is if there's a vulnerability. Those are like the two main things. Okay, let me catch up on questions here. What are some ways you think cybersecurity leaders can better vet vendors in the space? Everyone promises the world fast implementation. Yes. So I would say that is true. I'm just going to leave it on this slide. I'll answer your question, but you can be looking at this. This is the CIS critical security controls. I'm on the editorial panel of this. I was, part of development of the last 5 versions, but version 8, spent a lot of time with version 8. We're actually working on 8.1 right now for next year. But these are the things that are the fundamental things that still apply to the cloud: asset management, data protection, configuration management, account management, vulnerability management, log management. I mean, you do like the first 8, and those are all the basics. And these are all fundamental foundational things. So going back to your question about tools, I talk to more vendors than almost anybody. I work with lunch video capital firms. They come to me, the vendors come to me. I've talked to everybody. And what you really want to do is the tool needs to match your level of maturity and your capability of what you can do with it. Because it's just like cars, right? You could say the perfect car is a Mercedes S-Class because there's all these features, but not everyone can afford it. Not everyone can drive it. Not everyone can, needs all of those features. There is not one best thing for everybody. So you need to really pare down to the things that are most important to you. And it's important to be able to say, what are my gaps, and have those requirements, because they're just going to tell you they do everything. And you're like, well, I only care about this. And they say, well, that's one of the 15 things we do. And I'm like, well, I don't need the other 15 things. And then you talk to one that does this one thing that you need, more in focus than the other 15 things, is kind of like the short answer to that, since I have a bunch of questions I need to stack up to. Okay, 2 more that I have. How can security be managed while having hybrid cloud? In the same way, it's just understanding the differences in hybrid cloud, where some of the stuff is on-prem, some of the stuff is in the cloud. There might be things going back and forth, making sure that the security protections and detections are the same in both, and that it feeds into a single process. Because that's going back to the first question, is why are leadership not understanding the cloud, is because they think it's the same thing. And so the logs that you have on premise, in your, let's say your database is on premise, you have that and you have absolute control of it. But when it's in the cloud and you're talking about your application servers, or you're talking about your credential management, you may not know where those logs are. And they may not be easy to get to. And you may have to write scripts to get to them. And so and then what does it feed into as a, protection, detect, respond, recover, right? That I have that same process. That's the most important thing, is it's consistent, because a lot of times something happens and you're like, okay, well, I see it here, but I don't know where to look in the cloud to be able to do to get my full understanding of what's there. And then what's next in cloud security, anything exciting coming down the pipe? Um, I don't think that anything like specific cloud security. I mean, obviously, could talk about AI and generative AI and all those things, what they're happening and how they may be included in that. But, um, you know, it is another iteration of computing, right? It's like, what's new and exciting. And, if you would ask me 10 years ago in computing, it was like, okay, well, the computer is getting smaller and faster. Great. In cloud, they're getting more diverse and faster. And I think we need to work on resiliency, because I think we put a lot of emphasis and a lot of trust in the cloud security providers to handle that for us. But it's your responsibility to be able to know, if something goes wrong, you're the one that's going to have to respond to it. And particularly when we get to, um, I guess I had said it before, that you're responsible for compliance. You can't say, oh well, Amazon has a SOC too, so I have that. It's like, no, the application level and how the data is protected and how the accounts are managed are all on you. Remember all those the top 10 and top 12 issues that we had in cloud security? They all related to that. So I wouldn't say there's anything exciting because it's still somewhat new, and people are still kind of expanding into it and realizing the capabilities of temporary workloads and expanding the, diversifying and locations and things like that, maybe getting things a little faster. But yeah, okay, another question. My thoughts on the cloud firewall. Well, it's kind of inherent, right? In software-defined networking, in these micro segmentation, because your network could be all within one device, that you have multiple networks with lots of different virtual systems or containers, and you will have, for all intents and purposes, a firewall that maintains that segmentation, because this micro segmentation is a thing that is unique to the cloud that we don't really have in data centers. One of the other advantages of cloud from a security perspective is that micro segmentation, where in data centers and in premises usually was a flat network. 10 years ago, I'm in an organization, and like I said, I ran pen test teams back in the day. I'll say 15 years ago, I could scan across an organization. I could get everywhere in the world because it's one big flat network. And they may isolate the applications, but the isolation is to the application network. So now in the cloud, we have micro segmentations to specific workloads, and all of those are using firewalls, and intents and purposes, that are software defined. And so that's the other interesting thing, is I hate, to have a presentation where you never had hear the word zero trust, but I'm using it as a reference, is that, you know, all the stuff that has been talked about in that topic, which I will not say that word again, is things that the cloud does inherently. And we realize in the last 10 years, which is why it became such a popular word, is that we're not doing it anywhere else. So how do we do that in making sure that we're dealing with our credentials and our systems and our network and our applications and our data, the 5 pillars of that word, properly, is because it's done that way in the cloud. And so it kind of inherently comes with that, which is an important thing. So my last slide here is just really about the takeaways. When I talk about credentials, ABAC is attribute based as opposed to RBAC, which is role based access control. So just because I am a comptroller level 3 and I get these rights to access these systems, it's more about the your attribute base, which is, what do I do, when do I do it, what are the things I'm doing? And that could, because it's not just about the humans in the mix now. Most of the accounts in the cloud are service accounts, so you have APIs, you have workloads, you have temporary things that are running, you have all these different things. So it needs to be about, what is this thing, this entity, what are the attributes of it to give me rights, not the person. Understanding the attack surface, I kind of talked about the telemetry. It's all about configuration management and vulnerability management and keeping up with that. And then know where your data is. There's a big joke because we talk about Gen X, which I am, that, in the 80s, there was this thing that it's 10 p.m. Do you know where your kids are? It was like, and everyone kind of laughs at that. It's like, yeah, no, they had no idea where we were doing. But yeah, we need to know where the data is because it's going to be distributed in different places, maybe on-prem, maybe in the cloud, maybe in multiple areas. Okay, one more question. Well, before I end, and then I'll open up for more questions. What process should be in place to prevent data spillage in cloud environments? It's not any different than what you would do on-prem. It's just knowing where it is, because the thing where you get in trouble is with all these development environments. One of the most common things is you'll find production data in development environments, because it's so easy, just like make a few clicks and spin up a new development environment. And then there are tools to help manage the data across them. But instead of, because if we go back 15 years, I had to buy systems, set them up, plug them in, turn them on, and then put my development environment on it. Now if I want, 4 different development environments, I can just spin them all up, and I can have, dev or pre-dev or pre-production or staging or whatever, because it's inexpensive generally for me to do that, as opposed to it was before. So you have all these different development environments that you may not realize they're using for other things, and knowing what the data is. So again, it's, where your kids are. I guess it's exact same as my final point there, is like, know where your data is. And then importantly, like, what sensitivity is because to that data, because if you have production data in a development environment, is it protected the same way as production? And do you have regulatory requirements because it's financial data, healthcare data, whatever, in the development environment, because that's going to get you. And then, knowing where all goes. Backups is another thing. Do you know where the backups are going? Because they may come down to on-prem, they may be going to another instance, kind of knowing that data flow, which goes back to the threat model. The threat model will help kind of define all those things. Okay, down to the last 2 minutes. And I think that is the last of my, well, I should know because I did the thing. Yeah, so that's the last of my slide. If you have any additional questions. But resources, the Cloud Security Alliance, I can't hype them enough, because they have a lot of free resources and papers and articles and things to understand cloud security. There is a in-person event in September called the Sectember event, Security September event in Washington State, in Seattle, in September, for the Cloud Security Alliance. There is always a lot of regular information out there. It's one of those things where when people ask me, it's like, how do I learn about security? I'm like, just Google it. There's more information than you can ever know. The same thing with cloud security is there's a lot of really great information out there from a lot of different sources on things to worry about. But the important thing is it's got to link back to your business. What is your organization doing? And if you have workloads in the cloud, what is it? What's the criticality of the business? How sensitive is it? Does it have specific regulatory requirements or contractual requirements with your customers, SLAs to keep up, requirements for protection, and making sure you're meeting those? And the thing that you need to be able to meet those is a telemetry to know, like, what do I have and where is it? And how do I know if it's being protected properly? And how do I know if something happens to it? Because being able to put in detections to alert when something goes wrong, and there are tools that can do that, and there are things you can script to do that, is very critical. And then more importantly, if you have an incident response process, make sure that you review it, that it takes in consideration for cloud workloads, because that's a very different process than what you've done traditionally. And at this point, I will stop, and I will thank you very much for your attention. I hope you had a great conference, and have a great rest of your week.
Thank you again, Rick, for such an incredible keynote. I also want to thank everyone else for joining us today. This session, along with all of today's content, will be available on demand following the event. This officially concludes the Argyle CISO Leadership Forum. We would like to give sincere thanks to today's sponsors, Lookout and Hawks Hunt. Today's event would not have been possible without their support. Thank you again for joining us today and engaging in our content. Have a great rest of your day.